Good day, class, and welcome to our new unit. We are moving to Unit 11 in the textbook. Specifically, we're looking and starting with Section 4 from Chapter 11, which is on three-dimensional figures. So we're going to be working with things like volumes of composite figures. We're also going to mix in some work with units, so that lesson on dimensional analysis will be handy as well. So let's begin. So really, when we start talking about three-dimensional figures, we're talking about things like prisms, spheres, cones, pyramids, cylinders, etc. But really, at the most fundamental root of everything, it goes back to our polygons. So let's do a quick review. What exactly is a polygon? Well, a polygon is a closed plane figure that's formed by three or more line segments. Now, you'll recall when we talked about polygons back in the previous chapter, we said that not only do the sides of it have to be formed by segments, so there's not going to be any curves to it, but in addition to that, those segments are going to have to meet at endpoints, and the figure must be closed. So there can't be an opening or a gap between any two sides. Now, if we take multiple polygons and join them together, we create a polyhedron. So a polyhedron is a solid whose surface consists of polygons, which are called faces of the polyhedron. So if the shape has, we'll say, triangles for sides or rectangles for sides, etc., then it can be considered a polyhedron. Now, if we take a look at our example, here we happen to have a triangular pyramid, and you can see in this case, the faces, the sides of the shape, are going to be, in this case, triangles. Now, in addition to that, we have the edge, which is the segment where two sides meet. Then there's a point, and the point is where three or more sides meet. That's referred to as a vertex. So the edge of a polyhedron is a line segment formed by the intersection of two faces, which have to be polygons, of a polyhedron. The vertex of a polyhedron is the point of intersection of three or more edges of the polyhedron. So, determine whether each of the following is a polyhedron and give a reason. Well, if we look at our first example, you'll notice that every single side of this particular solid figure happens to be a rectangle. Since rectangles are in fact polygons, yes indeed, this is going to be considered a polyhedron. Now, if I look at my second example, notice that the base is a circle. A circle cannot be a polygon because we cannot have curved edges. So therefore, since the base is a circle, this example of a cone is not considered a polyhedron. In our third example, all of the sides look like they are triangles. Since triangles are considered polygons, this is a polyhedron. Now, polyhedrons can be classified as either regular or irregular, just like when we discuss polygons being regular or irregular. So if it's a regular polyhedron, all the faces of the polyhedron will be congruent to each other. So they're essentially all congruent. For example, all squares, all equilateral triangles, all regular pentagons, etc. An irregular polyhedron are when the faces of the polyhedron are not all congruent to each other. Now, sometimes people confuse the concept of polyhedron and solid figures. All solid figures do not necessarily have to be a polyhedron. We have the examples of the sphere, the cylinder, and the cone. They are solid three-dimensional figures, yet because their sides are not created by polygons, they are not considered polyhedrons. So, how do we name polyhedrons? Polyhedrons are named based upon the shape of their bases. And this is really going to be working with prisms and pyramids. So in a prism, it's named on the sides. Now notice the two sides, we call them bases, that we're going to use to create the name, they are always going to be parallel to each other. And the sides that connect those two parallel bases are going to be either rectangles or squares. So here in our example, we have a triangular prism. A rectangular prism, again, the two bases that are parallel to each other will be rectangles, and the sides that connect those two, that join those two parallel bases, will always be rectangles or squares. Now with the pyramid, slightly different in that now there's only going to be one base. Again, the sides that come up to the point, though, they're always going to be triangles. Now with the cylinder and the cone, these are usually easier to spot and easier to identify because the cylinder will have two bases that are circles. They will be parallel to each other. And the cone will have a circle, and then it's going to come to one point. So again, there's only one circle, one base. So again, we name the figure based on the shape of the bases. And again, a lot of times I get the question, Mrs. O'Connell, how do I know what the base is? Well, when it talks about the prism, the bases, I like to think of it this way, they are the unique sides. They're unique, they're different. They're not necessarily going to be rectangles. So if I look at this first example, notice we have two pentagons, and they're parallel to each other. That's going to be my bases. They're unique. It's something other than a rectangle. And that's not to say we can't ever have rectangles. We do have rectangular prisms. But the first thing we always look for are the unique shapes, because that's going to be indicative and kind of help us out in figuring out what its name is. So this would be a triangular prism. Now, if there's only one base and it's going to a point and the sides are triangles, we know it's a pyramid. And since the base of this pyramid happens to be a triangle, we will call it a triangular pyramid. Now in our third example, in this example, you'll notice that again, we've got to look for the unique shapes. And there's two of them here. Two trapezoids. The rest of the sides are all rectangles, but it's the trapezoids that are unique, that are special. And because they're parallel to each other and there's two of them, we're going to say this is a trapezoidal prism. So our next discussion is the net. Now the net is defined as a diagram of the surfaces of a three-dimensional figure. It can be folded to form the three-dimensional figure. You could also think of it as if you took the three-dimensional figure and you unfolded it into little parts. What would it look like? So here we have the net of a rectangular pyramid. Now looking at this, you can see again, we've got the four triangles. All right, and so that's indicating to me that this is going to be our pyramid. And because the base of it is a rectangle, we know we're going to have a rectangular pyramid.